Right. In this station, we are going to be looking at the relative strengths of acids and bases based on the number of free ions in the solution. If you look at beaker A and B, you will notice that beaker A has less free hydrogen ions. Those are these little circles that are not attached to anything. And beaker B has more free hydrogen ions. We can say that beaker B completely ionizes, and that beaker A only partially ionizes. On the page next to this, we are going to take down 4 definitions. A strong acid is going to ionize completely, and there will be lots of free hydrogens in the solution. A strong base will also ionize completely, and there will be a lot of free OH- ions in solution. On the other hand, a weak acid will only partially ionize, meaning you will have less free hydrogens in the solution, while a weak base will also only partially ionize, meaning you will have less free hydroxide in the solution. If you look on the next page, there are 3 questions that we are going to try and answer right now. The first one asks, which beaker contains the greatest number of free hydrogens? Those are the little circles that I drew the arrows pointing to, and at this point you want to answer that question, beaker A or beaker B. The next question is, which beaker would be less acidic? So if we look at our definitions on the previous page, the less acidic is going to be the weaker acid, so it will only partially ionize. You should be able to answer that question right now. The last question is, which beaker would have the lowest pH? The lower the pH, the stronger the acid. Take a second to answer the third question. You should have had for your answers that letter B would be the greatest number of free hydrogens. Letter A would be less acidic or weaker, and letter B would have the lowest pH or be the strongest acid. The next part will be a demo. The free ions are able to conduct electricity and are called electrolytes. The more ions, the stronger the acid, and the brighter the light would be. What I'd like you to do now is take a look at the following 5 substances and make a prediction of whether you think they will be a strong or weak acid. In other words, if these substances were to power a light bulb, would it be a strong light or a weak light? I'm going to show you the 5 substances now. So they are all clear liquids. And here I have a device. This is going to be the light bulb. These are the prongs that are going to be connected, and we are going to put the solutions in and determine how strong is the light. In other words, how many free electrolytes are there? So make sure that you have made your predictions. You can write strong or weak. Right? What I'd like you to do now is we are going to be testing out the 5 substances, and you will be filling in this relative brightness column. You can rate the lights from 1 to 10 on how bright they are. So 0 would be no light, 1 would be really dim, 10 would be super bright. So the first substance that we're going to test is hydrochloric acid. And that turns the light on. You can decide how strong it is. The next substance that we're going to test is vinegar. So you can see that the light is glowing, but it is not nearly as strong as the first one. The third substance is soda. My soda is Sprite. And And you should be able to see that the apparatus is not turning it on. So in the soda, there are not enough electrolytes to turn on the light bulb. Our next solution is going to be ammonia. And our last solution is the 0.1 molar NaOH. So you should be able to fill in the relative brightness rated on a scale of 1 to 10. And now we're going to answer two questions. So on the bottom of the page, I would like you to answer the following two questions. Which of the 5 substances ionize completely which only ionize partially, and the third question is which don't ionize. So remember, the stronger the light, the more it ionizes. The weaker the light, the less it ionizes. And if it does not turn on the light, that means there were not enough free hydrogens or hydroxides to turn it on, so it did not ionize. Once those questions are answered, I have one more question for you, and that is going to be on the page that we took our definitions on. I'd like you to draw the following 3 beakers. Draw in the hydrogens and the hydroxides, and then your question is going to be to determine whether each beaker is an acid, base, or neutral, and to identify if it is a strong or weak acid based on the number of free hydrogens and free hydroxides in the solution. Good luck.